So if everyone's ready, hello dear authors, invited guests, and welcome to technical session 2A. Good morning, good afternoon, good evening, wherever you are. It is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems, Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19. And making this conference more productive. We also wish everyone and their families a protected time, and we will all together pass this soon. We hope you will enjoy 2 days of this knowledgeable and interactive sessions. Just before we get started, I would like to introduce you to our chair for this session, Alexander Rykov. So just a bit more about Alexander. So he's a professor of Doctor of Technical Sciences, State Advisor of the Russian Federation of the Third Class of the Russian Government Award in the field of Science and Technology, Professor of the MIREA, Russian Technological University, leading researcher of the Institute of Control Sciences of Russian Academy of Sciences, Head of Artificial Intelligence Department of the National Center of Digital Economy of the Lomonosov Moscow State University, Director of the Center for Artificial Intelligence of the International Research Institute of Management Problems, scientific leader of the Expert and Analytical Center of the Institute of Tax Management and Real Estate Economics of the Higher School of Economics. So just to get started. Thank you, sir, for chairing this session. Now I would like to start with the papers. Also, there's a special note for the presenters. You'll be given 12 minutes for the presentations. On 10 minutes, I'll raise a gentle reminder and request while the presentation is going on, other participants kindly be muted. So I'm just gonna, the first paper, the first presenter will be Adnan Funun. He is from the Hassan First University of Settat in Morocco, and his paper title is Agile Governance Supported by the Frugal Smart City. So Adnan, over to you.
Do you hear us?
Hello, yes. Adnan, are you there? I don't think so. Let's move ahead with our next presentation.
Yeah, I'm Aruna.
Okay.
The next presentation.
Good evening, one and all. Am I audible?
No, just a moment, Aruna. I think so. We have our first presentation, Adnan.
I think he's just joined now.
Yes, yes. Perfect.
Okay.
Hi. Hi, do you hear me, please?
Okay.
Yes. عندنا فون مراقب.
Hello, Adnan. We can hear you. Will you be sharing the screen today?
Exactly. Yes. Okay. You can see my laptop.
Yes, we can see your screen.
Hi. Okay. Okay. I will start when you authorize it. Okay. Can I start?
Yeah. Go ahead. Whenever you're ready.
Okay. Okay. I'm Adnan Funun from Morocco, and I'm here today to present my paper entitled Agile Governance Supported by the Frugal Smart City. This paper is written by Adnan Funun and Awatif Hiyar and Qabil Safar and Abdelkarim Haqiq. The summary of my presentation is like this. And first time, it's an introduction, and after this, research goal and methodology, post-crisis participatory governance gamification model, Morocco case, and after this, discussion and conclusion. Today, the challenge after the COVID-19, it's so important. The COVID pandemic has disrupted direct and indirect actors in different countries of the globe. No one was prepared to counter to the spread of this pandemic. During time of pandemics, a considerable drop in consumption at household level is recorded. The supply of labor that is reduced because of the pandemic. This climate has a crucial impact on business investment and generates significant social phenomena in this past pandemic. Faced with this situation, all countries reacted to mitigate the impact of the pandemic with different approaches. And the context has enabled smart city to stand out quickly. This mainly due to the rate of integration of new technology in this type of city, like IoT, machine learning, and other technology. On this paper, we seek to present and to put forward a global solution for the post-COVID on the basis of mixed human technology-driven approach. This solution came to ensure frugality and resilience throughout the integration of citizens at the level of our play, as well as preparing a framework of agile governance, smart city, through an integrated process. The research goal of this presentation and methodology, a question asked before writing the paper: where is the citizen in the process? How can the smart city serve the citizen through the participatory approach? And can the sustainable human technology-driven approach present a frugal and resilient solution for the post-pandemic? The use of concept of the game can be used for integration of citizens in the project initiated by the city as a part of response of the post-COVID problem. The objective of this paper is define a system of governance at stakeholder level and centered on them and prioritize access of intervention. Post-crisis participatory governance model. On this paper, we put forward a smart concept of smart city Casablanca. This concept of smart city that came to bring out a concept of frugality as well as be oriented use of new technology for the benefit of stakeholders of the city. This model came to illustrate the use of technology while applying the participatory governance. This governance which based on upward and downward communication while remaining in direct contact with citizens. Like you see, you have a human technology approach, and you have a bottom-up approach and top-down approach between all components of city, citizens, enterprise, governance, and authority. The concept of gamification seeks to use the game in real life context to highlight such concept. Technology take in a rampant place as so to prepare the ground of the stakeholders. The reason why smart city may be more suitable to support such experience. The gamification is based on several tools and methods to encourage the player by using several methods, for example, point, badge, mission, trophies, and achievement. In this context, gamification can positively influence the behavior of actors to revitalize the access that have been impacted by COVID-19. In this paper, we study the following axes: financial, healthy, economic, and technology. In this example, you see financial. You can evaluate it by vulnerability by using indicator. For example, if you would take the financial part, we can judge the health of finance in the city via its indicator: employed population and population living in poverty. And you have less level of vulnerability in this axis. Less vulnerable L1 and L5 is more vulnerable. The methods, it's like this. In the first time, we prepared data in this part. We prepared our data before using the prediction model you have access, you have data, and now you prepare data to prediction model. Initially, we convert all value to real numbers because we need to predict the value of the year 2021 of each indicator based on data collected between 26 and 2022. The model, our goal is to predict the future value of each indicator for the year 2021 based on data collected between 2020X and 2022. To this, we use time series forecasting. There are many types of time series forecasting methods in our work. We use autographic integration moving average modeling. The vulnerable assessment, after this, when you have a model, you predict the new value, and after predicting, you have a level of vulnerability. For example, finance in Morocco, you have L4, it's more vulnerable. Population living in poverty, you have L1. Healthy, the number of medical staff, you have L2. The population without compulsory health insurance, you have L5. It's more vulnerable. Like this, you have areas, you have indicator, and you have vulnerability in city. After detecting vulnerability, you go to prepare a gamification model and game for citizens. The gamification enabler, their role is mainly to design and definition of different game scenarios based on the initial evaluation result. In this part, to design, specify with the various stakeholders that accepted objective and accept a reward. The integration of players, citizens, NGO, tourists, and company with the expert in description of the game scenarios is important in order to have a consensus around the game scenarios and to ensure that different scenarios are not rejected by players. For example, if you take economy and financial area, in this chapter you have application on areas, goal and scenarios for game, player goals and awards, and business objective. Why you play, but it's a side of city. Why city prepare this and the objective of this game. The game, for example, about financial, the game aims to motivate business to create local employment and local investment. The game will take place on a web platform. Company must have access to a platform to declare the number of local employees recently hired, as well as the investment made at regional level. Ranking will be published at the end of each month to show the community the company most involved locally. The player's goals and awards, for this example, the enterprise local job creation and encourage local investment badge. You have a badge, like the goals is to create more job, and the words for enterprise, it's badge and communicate about this enterprise in the city. The business objective for this example is develop awareness of local business and improvement of the company's social commitment. In this example, we show the whole system for gamification in our example. For example, if you take in this you have two major points: decision maker, and you have 5 areas. You have financial vulnerability, you have healthy, economic, technology vulnerability, and exposure. And you have in the other side, you have the gamification engine. In first time, you collect all data, and after this, you predict the area more vulnerable than other. And after this, you have to gamification. The most important side in this engine is to integrate citizen in game presentation, and you have a database about evaluation process, game database, and the citizen profile enterprise to prepare game and scenario game adequate with requirement and with the attention of citizen and profile enterprise. Discuss and result. The integration of stakeholders in deployment of post-crisis projects presents an important opportunity for the city. The collection and intelligent use of data is so important issue for improving the governance of the city through the prediction of the vulnerable acts of the city. The game scenario established at the level of gamification can reduce the vulnerability of the access studied, as well as improve the participation of citizens in the daily management of city. This sequence came to materialize an approach of intelligent governance centered on a human technology-driven approach for the management of crisis situation. The smart city of Casablanca, as already described at the start, highlight an ambitious project that's called on the concept of human technology-driven approach, the concept of the frugal smart city, improve our vision and our perception of intelligence by taking into account a collective intelligence and technological progress at the same time. Conclusion, COVID-19 can present a real opportunity for smart cities to stand out quickly, and this concept of gamification adds a layer of trust between decision maker and the various other actors of the city by integrating them into a collective decision-making process and of purely participatory democracy. Something that will allow the smart city to follow the needs of the citizen and build a framework of participatory democracy based on technology for the service of a human. We also presented a general framework for gamification by integrating the various interested parties and mainly the citizen-driven human technology-driven approach for the management of crisis situation. And all this more precisely for the post-crisis situation draw an integral solution, participatory and above all frugal. The perspective of research, our work or our paper came to initiate a serious reflection of integration of the citizen in public decision making to further develop the concept of smart cities, as well as to make the citizen in an active actor in the process of management of city, and especially to empower the other actor in making city governance a common subject. Thank you.
Thank you, Adnan. Alexander, if you've got any questions for the presenter.
Okay, one question,
Okay.
please. I have one question. As I understood, you work with a group of people, group citizens. Do you use any special technology methods for making the decision-making process in group of people more purposeful, more sustainable, more accelerating? Okay, what can you tell me about it? Group of people and very
Thank you, Professor Alexander. For this example, good. For this example, you use a platform. In this platform, you have all suggestion and all suggestion taken by citizen. Citizen take and have a profile in a platform, and he suggests or he presents our.
Okay, thank you. I understood about problem, but there are some very interesting methods of make the process decision making in group of people more diversion, not conversion, more conversion, more quick. They make it quickly. Thank you very much. I understood about platform. It's very nice. It's very nice idea and good results. It's very. Thank you.
Thank you, Adnan, for your presentation. Thank you for your answer to Alexander's question as well. So, just if anyone else has any questions in the audience, please use the chat function for that. And just to move on to our next presenter, she's Beatriz Batista Cardoso from the CERTI Foundation in Brazil, and her paper title is Development of Real-Time Simulation Laboratory for Energy Utilities. So whenever you're ready, Beatriz.
Hi, can you see my presentation?
Yes, we can.
Okay. Hello, everybody. My name is Beatriz. I'm from Brazil. I work at CERTI Foundation. Today, I'm going to present the paper called Development of a Real-Time Simulation Laboratory for Energy Utilities. The study presented in my paper is part of the Urban Futurability Research and Development Project by Energy Distribuição São Paulo. The project was carried out in the city of São Paulo, Brazil, in a region with a high load density and about 20,000 consumer units of the residential and commercial types. One of the main pillars of the project is the implementation of advanced protection schemes and self-healing for an automated and optimal grid operation, and conversion of a portion of the overhead grid to underground in order to improve resilience and also developing new technologies for underground constructions. The Simulation Lab initiative is summed up in the development of a laboratory designed to develop new protection techniques for distribution grids and substations. The structure of the laboratory will also provide an adequate environment for testing and approving new equipment to be inserted into the electrical power grid. The main equipment of the laboratory will be the real-time simulator. This equipment assists in the study of the electrical grid's behavior with simulations in real time or offline, with the benefit of the possibility of optimizing the distribution grids. The real-time simulator also assists in the company's digitalization process, developing digital simulation models of the distribution grids. This initiative aims to carry out tests of protection philosophies using the computational capabilities of equipment with high processing power dedicated to the simulation of electric power systems. In principle, tests will be implemented to validate self-healing, adaptive protection, and logical selectivity philosophies. Later, the laboratory will be used to test protection and control schemes that may be implemented and used by the company and other companies of the Enel Group, in addition to simulations of failures and how the distribution grid behaves in these situations. The development of the real-time simulation laboratory for the UF project applications will provide the laboratory with vast simulation scenarios, including the peculiarities of the distribution grid in the city of São Paulo. This project covers a noble region of São Paulo with an area of 2.12 square kilometers, including different types of density load, different grid topologies, different types of transformers, and new protection methodologies to be simulated. The figure presents the cycle that the laboratory proposes to perform with tests, validations, and simulations. The lab will be equipped with several devices, such as switches, router, concentrator with mini SCADA, network GPS, protection relays, HMIs, reclosers, IEC testers, etc. The greatest advantage of the laboratory will be the real-time simulator. The equipment will provide simulations of the distribution grid's behavior and the equipment connected to it in a more assertive and current way with reality. Computationally, it is a very powerful equipment, performing simulations with other equipment or creating visual equipment for the simulations, presenting a customizable environment for the simulations. It is expected that with this construction of the simulation laboratory at the headquarters of Enel São Paulo, we reduce the time of application of new technologies in the distribution grid, whether in the area of automation, protection, or telecommunications. Another point is the possibility of simulating faults and expansions in the distribution grid, helping to solve problems and allocate resources. With the equipment available in the laboratory, the team will have greater knowledge to allocate loads more safely and how the grid behaves in certain situations. In addition to these benefits, the laboratory will also help other project initiatives in the areas of automation, communication, of the operating network, protection, and power quality. As an example, the underground fault tracking initiative seeks solutions to help find more assertively and quickly failures in the underground distribution grid. This laboratory will have the RGDM equipment, which will be used in the initiative. This equipment relay measures the electrical quantities of a medium voltage feeder, and through this performs its processing to detect faults in the grid. The device features a local display for viewing reading variables and some keyboards for performing basic settings. In addition, the device has 2 ports for communication, a fiber optic port for exchanging GUS messages, and an Ethernet port for configuring the equipment through the parameterization software. In the laboratory, we will be able to test other equipment that may be part of the solution for this initiative. As the simulation lab, we will have a test case up to 12 channels and a communication equipment for validating the equipment as a solution. For protection initiatives, the simulation laboratory is essential, as it seeks new methods of protection in the distribution grid, and before implementing these new protection configurations, tests must be carried out in the laboratory for validation. The laboratory will have relays and automated recloser switches, such as the Opal RT, which is the real-time simulator, in addition to the communication part mentioned before. So it will be possible to faithfully test the behavior of the distribution grid with the new methods applied and bring greater reliability to the solution. Protection initiatives also include the development of the software and firmware for the Smart Grid Gateway. The Smart Grid Gateway must guarantee a high availability of communication through the implementation of redundancy protocols, interface with IEDs, and cloud protection services. The Fiber Optics Communication Initiative proposes the development of a network with high reliability, availability, and data transmission rate for the underground distribution grids through optical fiber. The laboratory can provide redundancy tests in the communication, test the protocols used, and check the latency times. All of these tests will be able due to the presence of switches, router, and case to test communication in the laboratory. The distribution transformer census and low voltage control initiatives seeks to monitor the distribution transformer and generate alarms for failures that may occur. And in the case of low voltage control, it will also provide protection of the low voltage side with a motorized circuit breaker. Both initiatives in the solution have a remote terminal unit for performing calculations, receiving information from the sensor, and in the case of low voltage control, sending a command, and a modem for communicating and sending data. The simulation lab infrastructure will provide testing of the measurement and calculation acquisitions carried out by the RTU and whether this data is rising correctly to any central system. The predictive maintenance aims to predict equipment failure, thus being able to carry out maintenance before the equipment has a permanent failure or has a great impact on the electrical grid. For this initiative, the laboratory would work as a support, providing an infrastructure for the development of study regarding the correction of equipment failures. Equipped with telecommunication racks, automation, feeder relays, substation relays, and other equipment, as well as the automatic reclosers, all this equipment integrated with the Opal RT real-time simulator provide the company with a wide range of option simulations, like substation, distribution, high, medium, or low voltage, and communication, serving the entire field of activity. Thus, the differential of this laboratory for the others is the comprehensive area of operation, focusing on automation, protection, remote control, power quality, distributed generation, and the approval of new equipment. This study presented the development of the laboratory for use in the distribution company. This solution will provide the laboratory with vast simulation scenarios, including the peculiarities of the distribution network in São Paulo. The project brings laboratory with protective and automation equipment, telecommunication, test cases, and a simulator in real time, all this equipment integrated with each other. The simulation lab will provide with simulations of the behavior of the network and its equipment in a more credible way with reality, enable the team to provide a better service to its customers. If the laboratory success is consolidated, an opportunity opens up for the real-time simulator company to acquire new customers in the energy distribution area, with the development of new laboratories in other energy distribution units. In the case of Enel, the laboratory's success may provide for its expansion with the acquisition of more cores for the simulator in real time, and thus providing greater simulation capacity of the utility distribution grid, greater agility for the approval of smart grid devices, in addition to assisting studies of the power grid of the future. I would like to thank Enel Distribuição São Paulo and thank everyone for the attention. That's it.
Thank you, Beatrice, for your presentation. Alexander, if you have any questions for that presentation. I think
Yes,
your mic was on mute.
One question or two questions. Very interesting report. Can you tell me, you simulate the power system, but how do you take into account the subject in the events, the subject behavior in the events? Men, women, they are a component of the events. It's the first. And can you forecast the different unknown situation in your model?
Actually, our laboratory is still being developed. So, we received the equipment with a certain delay to the pandemic. And in addition, we are moving our headquarters, so we are not using it yet.
I think that this work has a very good future. Emergency situation and so on. Thank you. And the influence of people on the events. I think it will be in the future. Thank you very much.
Thank you.
Thank you very much, Beatrice and Alexander there. And if anyone else has any more questions from the audience, again, please use the chat function. So we're just going to move on to our next presenter. So our next presenter is Philipp Bruch from Furtwangen University in Germany, and his paper title is Security Threats of a Blockchain-Based Platform for Industry Ecosystems in the Cloud. So whenever you're ready.
Thank you for the introduction. I will try to share my screen. Right, can you see the slides?
Yes, we can.
Nice, okay. So thank you for the introduction. My name is Philipp Bruch. I work at the Hochschule Furtwangen University, and it's located in the Black Forest in Germany, and I'm active in some research projects, and one of the research projects is the research project Cosmos, which is such a system. So, and I will give a brief overview of the system, then talk a bit about the use case dynamic leasing we want to achieve with it, and then present selected security concerns of the platform. So, at first, Cosmos is a German acronym, but translated in English, it's something like a collaborative smart contracting platform for digitally value-added networks. Basically, it's a framework for the rapid development of cross-company business models. We want to achieve the dynamic deployment of trustable ecosystems, and also it's not just one system at all, it's differentiated in cloud-based and on-premise parts. And the basic thing we want to achieve with that is to depict and configure contracts between multiple parties. The driving factors of the project are machine manufacturers' use cases. So we are talking about CNC mills or industrial robots or stuff like that. And these use cases are supported by data science and especially machine learning. And the trust inside this or achieved with this framework is done by the blockchain technology. The project's still running until next year, February. And when we talk about the Cosmos Cloud system, this is the manufacturer, the machine manufacturer side. First of all, the system is configured with an identity and access management technology, namely Keycloak. You can use it to combine multiple Active Directory services or LDAP services into one realm, so the identities know each other in a certain kind of way. So we have a global reachable web application where we manage our Cosmos contracts. And for this, we're using the OpenID Connect principles, which is enabled by the Keycloak technology, which is configured with this global application. So here we have a brief layered overview of the global part. Currently, everything is based on Docker containers. We have stuff for security and accountability in front, and then we have our self-service web UI where we basically instantiate different Cosmos contract templates. The one I already said is dynamic leasing, and the other two showcases for the Cosmos project are transparent maintenance and proof of quality. Basically, then a big JSON object is produced, and what's inside of this object, we have configuration of the monitoring parts within our systems at the edge, so at the customer. We also specify the technologies to be applied at the customer. And using that, we reference specific images in a container registry, which is private. So this container registry is also configured with the Keycloak identity management service. Yeah. And obviously, every party involved in a contract must approve this contract to be executed. So, and when we talk about the machine customer side, the Cosmos on-premise system, as it's called, the first thing one has to do is to execute the contract management module. It's a piece of code. We have to configure it with our Keycloak credentials. So the account must be present in the first place. And then also note the URL of the global counterpart. Once a contract is activated, a basic ecosystem is deployed on cloud. This is also based on Docker, and here we have also our layered overview. We have our container engine, which everything runs upon. Currently it's Docker, but it also could be a Kubernetes cluster, dependent on whatever the customer is using. And so, yeah, this is the contract management system I already talked about. We have a message broker, which is an MQTT broker. And to achieve a certain amount of security, we have also a secret storage where we persist certificates for every container which is started by the contract management module. So, and I said before, the use cases are machine manufacturer driven. So obviously the customer will have this machine which is connected to its ICS, and we need some kind of connection to it. So basically we could implement our own connectors using OPC UA technology or Siemens S7 or whatever. Right. So, and how does this contract management module knows when a contract is activated? It periodically checks for new configurations at the global systems. This time it's no interactive way where we log in or something. We automate it using REST by applying the OAuth 2.0 principles, which is also supported by Keycloak. Then the contract is pulled, interpreted, and the automated configuration and deployment of scenario-specific images is achieved. And also, if the contract needs to be updated because some tags of some containers have changed or new versions are available, this contract management module will take care of the container lifecycle management. So let's go to our use case. As said before, it's the dynamic leasing of a machine where the machine utilization has direct impact on its leasing rate. So basically, if we treat our machine good, we have to pay less. So at first, there are many different and interesting things within such a scenario. And I only have time for a few points. Basically, we have a third actor within our scenario. This time it's the analytics platform, which receives data. This time the analytics platform receives our raw data. So we have to define our data flow within the contract. So, and if we apply our machine good, then we have to pay less. And this is defined within the tariff, which is configured within the blockchain. So basically, this is the configuration of chain code. So then we have to persist some of the data inside the blockchain, but we cannot do this on a high frequency basis. So we accumulate it, make some hashes of it, and just persist the hashes. So when we look at the technical side, at the customer which received the machine, we will implement or deploy a blockchain connector which takes care with a blockchain communication, and also we deploy an analytics container which talks to the service contractor, the analysis platform, which obviously must give something like a REST endpoint or an RPC call or whatever. And basically the billing is done by the smart contracting technology. So due to lack of time, I cannot show every threat and exposure we described in the paper, but here are a few. We separated them into 4 different types. The first one is human, where here's the example of social engineering. We all know that humans are also hackable. The impact is high. If we get hacked, the risk is critical. The vulnerability is probable, but we could also mitigate it by providing awareness training or execute behavior anomaly detection, and also we could apply principles like least privilege. When we talk about the infrastructure, here's the example of the patch deficit, where we do not apply continuous patch management, then it would be critical. The risk is middle and the vulnerability is probable. So when we talk about the business, here's the example for the sensor data manipulation. The impact would be absolutely critical. And so this could mean that in the case of the dynamic leasing scenario, the customer has to pay many, many thousands of euros, or at the other case, €0. Yeah, the risk is relatively low because we can monitor data at every point in our system. And also additionally, we could execute anomaly detection. So, and the last type of exposures is regards the smart contracting, where the example here is the input validation and error handling. So think about a smart contract, which is first executed, but then somewhere in the middle, it just stops. Okay, this could mean that some data gets persistent inside the blockchain, which should be not, or this could have critical effects on our compliance with the contract specification. The risk is middle and the vulnerability is probable, and we could mitigate it when we evaluate our input validation and consider the side effects of our error handling in code. So to conclude the paper, we executed a threat modeling in a distributed system named Cosmos. We separated the exposures in infrastructure, human, business, and smart contract specific exposures, and paid special respect to the dynamic leasing scenario. While doing that, we considered the Mitre attack knowledge base, which is very fruitful. And for future work, we plan to evaluate the platform through additional use cases. And also, we want to deploy a productive system at a customer, so one of our consortium members. So that's it. I hope I'm at the time. Thank you for your attention. Are there any questions?
If nobody have a question, I will ask if moderator agree me. Okay. If there are no questions, I will ask. I've seen on your slides very intriguing words. Anomaly detection. But what can you say about the possibility of your system to forecast or to be prepared for face and meet the emergency situation? How your system is ready to meet?
So, for example, if a human is in danger while working on a machine or something like that.
And you think that only human can make decision in emergency situation? But as I saw, you use artificial intelligence and machine learning.
Yeah, right. This is mostly applied for the analytics part, and
analytic special expert procedure. But more concrete, have you into your system the forecasting component? Forecasting
component
with the component which can make a prognosis.
Yeah, so it would be in the analysis cloud, for example. We have a use case where we perform predictive maintenance as part of the dynamic leasing scenario. So if the analytics cloud or system tells this customer you have to change this one piece on the machine, and he doesn't do it, it will have direct impact on its leasing fee, for example.
And we have 1 minute. And as I understood, you have this system work in the real practice, yeah?
Yeah,
You have contract with customers.
It's a prototype. We are still implementing it.
Still implementing.
Was it the question?
I wish you a success.
Thank you very much.
Very interesting.
Thank you, Philip, for your presentation and your answers to Alexander's questions. And again, if anyone in the audience has any questions for Philip, then please use the chat function. So just going to move on to our next presenter. And our next presenter is Sathit Prasompan from King Mongkut's University of Technology, North Bangkok in Thailand. And his paper title is Congestion Detection with Deep Learning Algorithms. So over to you, Sathit.
Okay. Okay. Hi, everyone. Today we'll present my research paper with name on gesture detection with deep learning algorithm by me, Sathit Prasompan, from King Mongkut University of Technology, North Bangkok. Today we'll present the detection algorithm for the Thai traditional dance. Let's start with the introduction. The target industry that have potential to the growth of the economy in the country and be able to increase the ability of competitive, include 10 industry. They have the gain to the interest investor from all over the world. These 10 industry can be divided into groups as follow. The first one is the extension of the existing industry, which consists of modern automotive industries, smart electronic industry, tourism and health, tourism, agriculture and biotechnology and food industry. They adding 5 future industry that comprise a new industry in which Thailand has competitive potential. They are consisting of industrial robots for industry, aviation and logistic industry, biofuel and biochemical industry, digital industry, and comprehensive medical industry. In the target industry mentioned above, the tourist industry is another industry that will affect to the income of a country. So the Thai traditional dance is one of the tourism industry that have potential for Thailand. At present, Khon or the Thai traditional dance show are becoming less popular in Thai society. The reason may be that the new generation is raised with the modern drama communication by speaking and natural gesture. Therefore, it is easier to understand modern drama than Khon show, which was more popular in the past. From this reason, we present the idea to apply the current technology into Khon performance, which is an art performance that has a long time. In Thailand, we use a program to detect picture using machine learning with gesture picture to train a model. The related theory in our research composed of 2 groups. The first one is machine learning, and the second one is about the image retrieval algorithm. For the first one, the one challenging in developing artificial intelligence to develop machine to learn and predict or create knowledge. Several techniques can be used to teach machine to learn and to create knowledge, such as deep learning, artificial neural network, support vector machine. The architecture of artificial neural network composed of 3 layers with input layer, output layer, and hidden layer. In our research, we use the deep learning with the deep learning is the extended version of artificial neural network that are created for machine learning. And for the second related theory is image retrieval. Previously, image retrieval of approach rely on retrieving image file name or using words that describe image, which is the image question, image caption. As a result, is incompatible with the existing huge database. So with the limited of the image retrieval approach, we rely on the retrieving image file name. So we will use the machine learning by using the deep learning to detect the characteristic of the type performance, which is own performance. And in the proposed method is composed of 2 models. The first one is the detection algorithm, and the second is the classification algorithm. We have divided the model into 2 models. The first model detect the character in the image. So this is for detect image in video, and the next we use the classification model to predict the gesture based on the greatest probability in the model. We use the cellular neural network to learn the model with the CNN composed of 13 convolution layer with composed of 1 style, 1 padding, and 6 mark pooling layer. And the learning rate is 0.001. And the number of batch is 64 batch. And in this cellular neural network, we use the activation function, which is the reactify linear units in our proposed method. And this is the input image. So we will detect, we will input the video, which is the Thai traditional dance, into the model. The input image in the model 1 will detect the cone character in the video. After that, we send the detected image into the model 2, which will classify the characteristic of each cone model. And the output from the second model is the characteristic of cone. So with the user who don't know the characteristic of each cone, they can learn what is it mean from this characteristic. So this is the proposed method. And in the proposed model, user can input any size and resolution image, as the program will convert the image size into 400 times 400 pixels. And as I mentioned before, our algorithm was divided into model, which is objective detection and image classification. So in model 1 is for object detection. And in this step, the cone character will detect the crop image will then put into the bounding box size and sent into model 2. And model 2 was for image classification. In this step, one of the cone gesture was detected using the greater gesture probability score. And this is the flow of our algorithm. It is the start and input image. And it will check the type of image and generate the unique code and process with model 1 with to detect the video character. And if it's found the cone character, it's crop the predicted image and process with the model 2, and it will classify with the 10 gesture class After that, it's return the output, which is the image, character, gesture, model, 3D, and description to the user. So this is the algorithm for detect and classification of cone gesture. And in the classification model, we have also used the image augmentation method for reducing the model overfitting by creating more than one image from one image. And we use this image to learn with our algorithm. So this is the process in our algorithm. And in this research, the dataset in this dataset were collect from Google Image, printed YouTube, and the requirement are as follows: is detect of 10 basic gestures, including angry, upset, resent, offend, request, crying, lost, death, decline, no, I, me, love, great, mighty, shy, smile, happy, there, here, and pointing. So in our algorithm, we'll classify these 10 basic gestures, and it will send the description to the user. And to training, the training model, we need to divide the set into two sections, with this train and validate the correction of the model, with this 80 and 20, with this train and test. And we use the number of epoch equal number of class multiplied by 2000, and the learning rate is 0.001. So this is the training, and this is the result. As we mentioned above, we classify 10 class, and for positive, true positive, and precision and recall will show in this table. And the multi-class precision will be 89.849%. This is the accuracy or the precision of our classification model. So the conclusion of this paper, this research aimed to develop a cone gesture detection with deep learning algorithm. Thai traditional art culture of cone was used. The main contribution of this research was to develop an algorithm for retrieving information from image for telling story inside that image. The interesting information inside the image will be retrieved to present to the interested people who is interested in its content. And development consists of telling story from image. So this is our conclusion. Thank you for your attention. Any questions?
Thank you, so if Alexander or if anyone else has any questions in regards to your paper, then please go ahead.
As usual, I can ask one question. You are talking about in your abstract. You wrote the words, the interesting information inside the image. As I know, the interesting information depend on the person who is retrieving the information. How can you retrieve or detect interesting information in the image?
Thank you for your question. In this research, the interesting information is the classification of the gesture. So the user can know what is the acting of this image, or this is in this performance. What is the type of this image? For example, what is the type? What is the characteristic of this image? So in my algorithm will detect this is their character.
For example, you try to find angry, yes?
Yes.
Okay.
Yes, if
characteristic,
the
emotion.
character angry, the algorithm can detect this is the angry, this is the smile, this is the shy, this is the crying or angry or decline.
Okay.
Yes.
It's very interesting tradition. Thank you.
That's perfect. That's everything.
And,
Thank you, Seth. Sorry.
And it's a theoretical. Is it a theoretical work, or you have a real practice? Where does it work in real practice?
It's from video. Each from performance from video, and we can capture the characteristic of the image.
Okay. Very interesting. Very interesting. And the plan for us, we have 1 minute, and the plan for future. Some words. The plan for future.
In the future, we can give some the description or provide the model for the interest for the user who interested in the performance. It will 3D model. Then the next will provide the 3D model for who interested in this performance.
I wish you the best and good application in real practice for people, share for people. Thank you very much. Very interesting tradition.
Thank you, Seth, for your presentation. Obviously, your answers to
Thank you very
questions.
much.
Very nice.
Thank you. And if anyone in the audience once again has any questions, please use the chat function. So just going to move on to our next presenter. So that is going to be Ikram Asghar from the University of South Wales in the United Kingdom. So his paper title is called The User Evaluation of a Virtual Reality Application for Safety Training in Railway Level Crossing. So over to you, Ikram, whenever you're ready.
Hello, can you see my screen?
Yes, we can see your screen.
All right. Hello to everyone. Good afternoon. I'm Ikram Asghar, and I'm here representing Center of Excellence in Mobile and Emerging Technologies from University of South Wales. And today's research that I'm going to present is user evaluation of a virtual reality application that we recently developed. And it is aimed at improving level of safety at railway crossings. So my talks contents as the standard one, as I'm allocated only 10 minutes, so I will try to keep the research content concise, that everybody has the idea of the research within the allocated time. All of are aware that railway is considered as one of the safest mode of transport all over the world. However, still there are concerns for the safety of pedestrians and the road users who are there, and the users have to cross the railway. And in everyday news, almost every other day, we listen about the incidents have been on the railway crossings, which results to either death or disability. And when we talk about children, they are at 4 times higher the risk of the adults of having these accidents at the railway crossings. That can be due to their inexperience and their behavior as well, because they are not as much exposed to these settings as the adults would be. We made a research into literature, and we came with these figures like for children between the age of 5 to 10 within UK, they will use 46% of times they will walk to their schools. And for the children between the age of 11 to 16, 38% of them walk to their schools, so which is a very high proportion, and they are all exposed to these railway crossings. Also, 95% of the road users and railway accidents which happen around the world, they are attributed to human factor. And that human factor can be the person controlling the railway gate, or that can be from the individual crossing it. Therefore, there is a literature say that pedestrian safety on roads and railway crossing is now of global importance. So considering this, we made literature investigation and we came to know that there is not a single approach that can remove all these accidents. There would be a multiple combination of multiple approaches. And 70% of the experts in this field, they believe that educational campaigns are one of the crucial factor for reducing these incidents. And these educational campaigns can be at schools, at different seminars, and especially when we talk about children, these campaigns can improve their education and skills like identifying safety at the railway crossing, judging their distance from the train and from the track itself, and managing their times and controlling their movements according to the environment. But for that, you have to provide them with the environment, whether it would be a real time or whether it would be a simulated one. So eventually the long-term goal is to focus on technology assisted solutions that can improve pedestrian safety at the railway crossing. So considering this, when we talk about their training, and if we have to take children to the real life railways crossings, it involves risks, it involves high cost, time and financial as well. And when you take children to there, especially with the like 5 to 10 years old, they may get scared. They can do some actions that can result into further incidents. And the second option is to build dedicated infrastructure. But I think this option has time and cost allocated to this as well. So therefore, we came up with the idea of incorporating such training through the use of virtual reality, which is famously used, especially with the children. They play games using this. So, and it will decrease the financial burden, time constraints, and it will have zero risk, which is the most important. They don't have any risk to their life while getting training in the VR environment. And another important thing is children can run through the scenario as many times as possible. It's not possible to take them to the railway crossing every day, but within VR environment, they can do it as many times as they want or their teacher wants. So when we looked into the literature, whether VR has been used for other trainings, we came to know that it has been used with many other training applications, including fire tunnel evacuations, for training mining industry employees, like car maintenance, surgical operations, and even in the teaching activities as well. But there was lack of VR-based training application for railway crossing. So that's why we came up with this project's idea. And the applications that I have mentioned above, they lack usability evaluation from the real user. That in our case is the school children and university children, university adults. So we used a co-design approach by involving 2 schools from Wales and 1 university into this research. And the VR environment, the prototype is consist of elements such as the physical world. They are very close to the physical world, like sky, grass, railway tracks, power stations, and road pavements. As you can see in this level crossing example. In addition, we incorporated the real sounds as well from the train coming from the gates itself, so that it gives you the impression of the real world. And the prototype consisted of 2 scenarios. The one is this level crossing, and the other one is foot crossing. And these are the most vulnerable when children have to use these, because there are no signals on these kind of crossings. And at the end of the screen, when you finishes your test, it gives you result as well, whether you have passed or failed. If you fail this test, then the children has to go through the scenario again under the supervision of their teachers. So when we conducted this study, we collected data as well from 83 school children and 16 university students. We used 2 questionnaires for data collection, a system usability questionnaire to test the usability of this application, and a sense of presence questionnaire to check the level of immersion. And we got ethical approval from University of South Wales Ethics Committee. We did this data collection in December 2019, and then in February 2020, right before the pandemic begins. So we included only 99 participants that we can gather data from at that time. The SUS testing result, we followed their standard data analysis process. On the left-hand side, in table 1 shows the scoring grade for that one, and table 2 shows the results for our survey. For the children aged between 11 and 12, their score was 80, which is excellent. I mean, which is grade A score, and for the adults, it was good. So because the adults, they have more exposure to real life environment, so their score was a little bit behind the children, but our focus was children. So we are happy that our scores are good for the children, which was our targeted population. And for these tables represent individual scores for each scenario. 38% participants from schools scored best imaginable, and 43% from the university scored best and imaginable. So if you look to the figure, you will see that most of the population score on best and excellent and good, which is really interesting, because we have published another study from this project that was based on the pilot study, and that study scored only 75% from 16 children. So we then made some changes on our prototype, and then we conducted this study with 99 participants, and that scored better, which is an indication that this prototype is close to the real world environment. And for the sense of presence questionnaire, we use 7-point Likert scale, and it resulted into 3 themes, being in the VR environment, and the theme 2 was like you will think that that environment is real, and the third one is you remembered what you did in your in that environment. And interestingly, for school children, they scored a little bit lower as compared to university student, which is an interesting finding itself. But looking at this slide, that even that finding is consistent with the existing literature, because the students of the university, they have more exposure with the level crossing and railway crossings as compared to students. So overall, the participants, they did show interest in learning, which was the most important thing of this project. And the SUS score interestingly decreased with age, as I indicated that the university students, they are more experienced than the school student. However, the sense of presence does increase with age. We believe that long-term adoption of this application can reduce the chances of accidents for children, especially who are 4 times more vulnerable than the adults. And that was the starting point for this project, that we thought we should develop something for the children. And currently we are in talks with other schools across Wales, because this project was funded with Welsh government that to run more trials. And at center of CMAT, we always believe in creating impact out of every research study that we perform. A company called Motion Ray is already in the process of adapting this prototype in their training program, because they already train people on safety, but they have to do it in the real world infrastructure with all those risks involved. So now they are in the process of adopting this to perform this in the VR environment. And they have already secured a funding from the Welsh government to commercialize this prototype. So in very near future, you will see this prototype being run across the schools in Wales, so that children, they can learn about the safety, how they can cross the railway crossings without getting into trouble. Thank you so much for giving me this opportunity to talk. And if you have any questions, please feel free to ask me.
Thank you, Krem. Alexander, if you've got any questions on that presentation, or if anyone else has.
If I can ask some questions.
Yeah, sure.
Oh, somebody wants. No, one question, please. You are talking about children, school children,
yep.
And children age 5 years old.
Yep.
But what do you think about the children 2, 3, 4 years old? Because the 95% it's too large, to some percent. The reason to some percent human
yep.
depend this accident. But what do you think about earlier age of?
You are exactly right. We did this talk with the companies who produce this equipment and with the Welsh government, because when you use this equipment, you have to put the headsets on your head, and they don't allow it to be used with the children under the age of 5, because after a few
Oh,
minutes you can get lost in this thing, and it can give you a bit dizziness as well. So it is not recommended to be used under the children of 5. And even with children between the age of 5 to 13, they can only use it for 5 minutes at one time, then they have to go to a break. But with adults, they can use it up to 15 minutes. So that was the one of the limitation, that we couldn't focus it on the nursery students, that is year 3 and 4. But I do agree with you, they are the most vulnerable, they are more vulnerable
very
than the
good.
year 5 students.
Okay, and technology question. Do you use any method of artificial intelligence, for example, for creating different unknown, unpredicted situation? Because
As
artificial intelligence can create automatically a different situation.
This is very interesting question. Yeah, in fact, Motion Rail, our partner in this project, they have got this funding, and they are looking into ways, because this was the only second draft of this second version of this prototype. Currently, it includes only 2 scenarios. One is foot crossing and one is level crossing, and that is already incorporated into the VR headsets. But looking forward, they are thinking about incorporating both artificial intelligence and other kinds of things into it. But it will take them 3 years to come up with the full version that will be commercialized as well.
Thank you very much. I think that due to you, soon the number of accidents will fall down quickly.
Yeah, this is our target as well. We will be really happy even if we stop one incident. I
The
think that would be a
person and
great
the number
achievement.
of accidents. Thank you.
That's perfect. Thank you very much, Ikram, for your presentation and obviously answers to Alexander's questions. If anyone else, again, in the audience has any questions, please use the chat function. So I'm just going to move on to the final presenter of this session. So the final presenter is Sadia Mahbub Mim from North South University in Bangladesh. The paper is called Machine Learning and Remote Sensing Technique for Urbanization Change Detection in Tangle District. Sadia, whenever you're ready.
Can you see my screen?
Yes, we can see your screen.
Hello and assalamu alaikum everyone. First of all, thank you so much to the panel of World Conference for accepting our paper for publication and giving us chance to present our work in such a big platform. Here is a small and brief presentation for introducing our research to you. The title of our paper is Machine Learning and Remote Sensing Technique for Urbanization Change Detection in Tangle District. Our paper ID is 144, and we are representing the Department of Electrical and Computer Engineering of North-South University from Dhaka, Bangladesh. And I am Sadia Mahabub Mim, the presenter of this paper. We all know that now urban growth is a typical marvel globally. It is obvious in non-industrial countries with current rapidity. Land use changes are inferable from the first urbanizations in recent decades in non-industrial countries. With the first growth of the populace, urbanizations in Bangladesh has occurred in the same way as other different urban communities of the world. To understand the land use change and urban development pattern, GIS, Geographic Information System, and remote sensing procedures are cost effective. In this research, Sentinel multispectral images are ordered in 4 land use classes, utilizing different supervised classification, including random forest algorithm. This study would significantly assist the urban planners through fundamental data about the degree and pattern of Tangle district's urbanizations to deal with the rapid urban development and give the essential urban drawbacks and benefits. Among all the districts of Bangladesh, why we choose Tangle district? Because Tangle district's urban growth trend is growing due to its proximity of Bangladesh's capital Dhaka. One of the main reasons we choose Tangle is the rapid change in its land in recent years. Many factories have grown in some areas of Tangle, changing the land size and region. These alterations has a major impact on the city's urbanization process, and also one of our author's home district is here. Here you can see in the map, this is the map of Bangladesh and the center of its the Tangle districts are shown. There are a lot of works on land changes, urban detection, urbanization changes, land changes, land cover, and previous work. But what is the difference between the previous work and our research? The distinctions between our study and the other studies is that we use the Google Earth engine to conduct supervised classifications after importing and exporting the dataset. For a clean perspective, we used multispectral Sentinel-2A pictures. We did not use any other source to eliminate the cloudiness from the images. Moreover, individual parts that we intend to categorize are labeled. Here is the flowchart of the methodology of our research. It is showing the one-by-one steps that we had done in our research. Our first steps of our work is to collect the images and filtering it. We use Sentinel-2A images, which is a high-resolution wide swath imaging project that supports land monitoring studies. After collecting satellite images, we filtered around 215 images according to the date, fixing in which time it gives the clearest satellite view. Because on other time there is not the view can be shown. The image are filtered to have less than 1% cloud coverage. In the figure, you can see the filtered image. There is the filtered image of the whole Tangle district. After filtering it, we need to label the images which can be shown the urbanization changes. We have classified the Tangle districts by labeling 1,500 polygons. Here is the small portions of the labeling inside the Tangle regions is visible in the images. Red polygons are for built-up area, green polygons are for vegetation, yellow polygons are for open area, and blue polygons are for water. And about the training and testing, we choose training samples and small polygons and validation samples as points to reduce the influence of spatial autocorrelations while still capturing the gradient of land cover from within each class. For training the data, divided the label images into two parts, 70% for training data and 30% for testing data. And we need to train the data into random forest classifier, which is a machine learning technique that used to solve regressions and classifications problems. The supervised classified package in Art Engine performs supervised classification using conventional machine learning algorithms which classify an image or a set of features as well as estimate classifications error using independent validation data. After finishing training, the results of classifications were shown on the map, and here are the classifications images from 2017 to 2020 as well as the overall changes in land in the Tangai district over the last 4 years are portrayed in that figure. And for the calculations of urban area, we have done the classifications for the whole Tangai district, but for analyzing the urban area, we choose Tangai Shodor Upazila for getting a clear result of the change of urban area. Here is the line graph which is showing from 2017 to 2018. There is a slightly change of the urban area, but from 2018 to 2020 there is shown big changes in urban area. For 2017, urban area is 7.0009 square kilometer, and for 2020, urban area is 7.0894 square kilometer. The changes of urban area within 4 years is 0.0885 kilometers square. To get a good accuracy of our research, we need a clear method which is going to show our result in a realistic way. In this study, the representations of the classification is basically based on the use of confusion matrix. That has usually a quantitative method to measure the land use and land cover classification's accuracy. A confusion matrix is an end-to-end matrix which compares the current goal values to the machine learning model's expected values. It is a method of summarizing a classification algorithm's results. To give a more realistic result, there is a used kappa coefficient, which is a mathematical indicator when the data is imbalanced. This is used to maintain only those instances which may have been correctly classified. This is the best method for measure the accuracy of classification. Here is the accuracy charts of our research. First table, you can see the accuracy level is changing within these 4 years time being, and same goes for the kappa values, which is also changes. And the second table, you can see the graph of kappa values. It is showing the differences among the 4 years, which is also changing. The purpose of our results to evaluate and assess changes in land cover over the last 4 years from 2017 to 2020. Tangai district's urban growth pattern is increasing due to its proximity to Bangladesh's capital, which is Dhaka, as we discussed at the beginning. In recent years, several factories have started growing up in various parts of Tangai, altering the land size and region. These changes has a major effect on the city's urbanization, and we tried to show these changes into our research. Our primary objective is to demonstrate this finding by evaluating recent land cover and urbanization shifts and using the remote sensing method to discover a growth in built-up areas. And lastly, this study is carried out to determine the level of urbanization and the scarcity of land points and polygons. The classifier makes better choices and predicts future improvements in growth and loss land patterns. Whether normal or artificial environmental considerations using the same size of training sample scenario. At the end, we'd like to say that this is not the end of our research. We will definitely increase our study and work on this, and our next goal will be we will utilize a variety of satellite images and a longer time period in different districts. We'll analyzing the urbanizations in different less developed areas using the same technique. And we will use a different algorithm and compare the results with our recent work. Thank you everyone for reading our paper, and also for giving chance to present our work. Thank you.
Thank you, Sadia. If Alexander or if anyone else has any questions for her on her presentation, then please go ahead. Sorry, Alexander, do you have any questions for Sadia?
Answering the questions of Sumit friend, yes, we use random forest classifier to method of the machine learning to choose that which area is leveling the point, and satellite images classifications are using for random forest we use for the classification of the satellite image, which measures the clear view of the images that we got from this particular area. And from other technique they use in deep learning method of this random forest, and we didn't use this random forest deep learning in random forest. So that is the different from other work in our work.
The question, we have 2 minutes for here, yes?
Yes.
You ordered the information on 4 classes. Do you think it's enough, or perhaps we need more detailed classes?
Yes, sir. This is not enough. We are working on this. We use Sentinel-2 images, which is basically giving only the 4 years, 2015, Sentinel-2 available from 2015 and onwards. So we use these 4 years, 2017 to 2020, for checking the urbanization changes. Our other Sentinel, among the Sentinel images and other images which is landscape, they are not give a proper view of satellite images. They are show some cloudy features. So we use Sentinel-2, and this that's why we use only 4 years. But we will work on it in future.
Okay, thank you. That's all.
Thank you for your question.
Perfect. Thank you very much, Sadia, for your presentation, answering those questions. I sincerely thank all of our authors for their excellent presentation and contribution in this session, and all of our participants for being part of this international conference. I hope this session was informative enough. All the presenters will be getting their digital certificates through the email within 2 working days. Further, all the papers that have been already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of WS4 2021. I also would like to thank you, our session chair, Alexander Rykov, for chairing this session. So I'm just going to share my screen here. So hopefully you can see that. And this is a token of appreciation to the chair on behalf of Team World S4 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir. So I kindly request everyone that they turn on their camera for a quick snapshot of the virtual conference.
Yes, thanks a lot, Alexander.
Thank you very much. Well, very good organization. I wish the best everybody, the member, a lot of emotions, very interesting and very fascinated and different aspects of very progressive themes. Thank you very much. Thank you very much.
Yes, thank you.
Thank you.
Yes.
Now we request everyone to please on their camera just for the virtual photograph. So this photograph will be shared with everyone later on. It's great.
Great.
Great to see you everyone here, and we will meet in physical next time. Okay, so
Hey,
cheers.
I think we will meet in physical in London.
In London, yes.
London. Yes, London.
Nice to see you everyone.
Thank you very much.
Yeah,
Thank you. Stay safe, everyone.
Bye.
Thank you, Naid.
Thank you.